This is a Raspberry Pi, a $35 networkable computer, and about the size of a credit card. It's a world changer. There's only one thing that's lacking, an easy way to obtain and process real-world analog data. That's where What My Nerd Instruments comes in. My name is Tony, and I'm VP of Special Projects here. We've developed a data acquisition system for the Raspberry Pi, and it's called the RasDas 1. In the same form factor as a Raspberry Pi, you get 8 channels of 10-bit data, running at up to 200 kilosamples per second. What's the voltage range? We let you decide. There's a user-programmable voltage reference, which sets the range anywhere from 0 to 5 volts in 127 steps. But you don't have to use it. If you want, you can set the range to be 5 volts, 3.3 volts, or use a temperature-compensated precision 2.5 volt reference, or even use your own external reference. Now, a lot of times the input signal is pretty small, but it's riding on some DC level. And you're not really interested in that DC level, you only care about that AC component. For situations like this, we let you choose between DC and AC coupling. You can AC couple a signal, crank up the gain. Since you've got an adjustable reference, you're in control. And look at that small signal using all 10 bits of resolution. ADC inputs tend to be pretty sensitive, and when you're working with electronics, it's all too easy for accidents to happen. Suddenly you've blown your ADC. So the RasDas 1 naturally has input protection circuitry to protect that ADC investment. For situations where you really want direct access to the ADC, we give you an access point. The RasDas 1 is all about putting you in control and giving you choices. Speaking of choices, remember when I mentioned that user-programmable reference and that you didn't have to use it? We didn't want to let that voltage circuit go to waste. If you think about it, being able to program a voltage is simply going from digital to analog. It's a D-to-A converter, just running really slow to provide a stable reference. So suppose we let it run fast, throw in some software, and you've got an arbitrary waveform generator. Our included software produces sine, ramp, saw, square, and custom waveforms. So when you use it as a programmable reference, the circuit runs slow and steady, and when you let it run fast, it becomes a signal generator. In the spirit of the Raspberry Pi, we're also pricing our data acquisition system at $35. We might just stop there, and you have a great system. But there's more. Remember the Raspberry Pi has an Ethernet port? Well, you can access it from anywhere on the network. We're including software to remotely control it. And here it is. It's our remote scope demonstration application. It works on your remote computer. It's Java-based, so it runs on Linux, Mac, and Windows. What it does is it communicates across a network to the Raspberry Pi, which is running the RasDas 1 remote server application. The remote scope tells the Raspberry Pi to set the voltage reference, the sample rate, and which channels to sample. When you click the capture button, it grabs analog data from the Raspberry Pi and displays it graphically on your computer screen. We've also got a remote spectrum analyzer application, which does something similar, but utilizes an FFT, so you can see your data in the frequency domain. By demo, I don't mean as crippleware. You've got access to the full program. By demonstration, I mean we show you how it can be done, and you can choose to make your own, to your own liking. We give you full access to our software API. The story doesn't really end with just a data acquisition card and software. If you've got a Raspberry Pi and a RasDas 1 accessory card, you really need some way to hold it. Introducing our adaptable enclosure system in 2 sizes, small and medium. Our small size can hold up to 2 accessory cards using additional risers. Our medium card gives you an open access area out front. The Raspberry Pi is held in place by its 2 mounting holes from the top, and our accessory cards are held in place from the bottom. Our card connects to the Raspberry Pi using a ribbon cable. Because the Raspberry Pi is on top and the case is transparent, you can clearly see the LED status lights. While the sides are open, there's easy access to all the ports. Finally, you can pop the top, and now you've got complete access to the card on the bottom. Now, the Raspberry Pi was targeted towards education, and we think that a Raspberry Pi, RasDas 1, would be a great way to get kids interested in science and math. But for kids learning in school, you need to acquire data from someplace. Enter the AudioExplorer. It's basically a connector card that brings audio signals into the RasDas 1 and the Raspberry Pi. There are 4 powered electric microphones, as well as 4 3.5mm jacks for microphone inputs. These can even be from an iPhone headset. Because microphones produce such tiny signals, we've included a high-gain amplifier to increase the signal levels. There are also 4 unamplified inputs, 2 using RCA-style connectors and 2 using 3.5mm jacks. Finally, to round things out, there are 8 LEDs, 4 near the microphones and 4 together in a bunch.
along with a general-purpose user-readable switch.
So what kind of fun things can kids do with the RasDas 1 and the AudioExplorer? How about measure the speed of sound?
With our high sample rate, and just listening for sound from two microphones at a fixed distance apart, we can tell the amount of time it takes for sound to get from one microphone to the next. Speed is distance over time, so calculating the speed of sound becomes easy. And since we can measure the speed of sound, if we know where a sound comes from, we can listen for echoes, and now we have a type of sonar rangefinder. You can use the RasDas 1 and the AudioExplorer to capture your data, and use the Raspberry Pi to perform the calculations.
So just imagine showing your kids how to measure the speed of sound, or finding the distance to a wall in the dark. We put together a website with detailed instructions on how to do just those types of activities. It's in a section we call Fun. If this sounds like something you'd like, let us know by kickstarting us. Depending on your support, we'll send you a RasDas 1 all the way up to our full enclosure system. Help me to bring the RasDas 1 to life.